start the first session. Ladies and gentlemen, we are about to start the first session of the ICA-ICST, I mean the International Conference on Artificial Intelligence and Computer Science Technology 2021, which is organized by Institut Teknologi Tangerang, Selatan, Indonesia, and supported by IEEE Indonesia sections. In this session, there will be 9 papers to be presented in this session. Started from Muhammad Raihan Fajar Al-Awalvian from University Indonesia. And the last one is from Abdul Al-Hamadi, Faculty Engineering, Media University. From you during session. Okay. So before we start, allow me to announce a couple things. As I mentioned earlier, there will be 9 papers. Yeah, there will be 9 papers to be presented in this first session, which is this. To announce you some things. The first one, time allotment for presenting your paper is 15 minutes, including key question and answer sessions. This one, the publishing time is 2 for the fastest. Download the conference certificate. Yeah. Our admin will share the link on. Yes, yeah. The last but not least, please need to take a screenshot you with this conference background. Please turn on all your camera. Screenshot. And we will share all pictures drive link in next 3 days. Yeah. Yes. We are still waiting for you to screenshot your picture with ICICST background. Miss Ban Ali, Mr. Tan, Hamadi, Mr. Ferry Wibowo, Wahyu, and Gegi Arjadi for you. Please, Mr. haven't turned on the camera with ICA-ICST background. Mr. Jonathan, can you please using the mirror background? It's like us. It's like Mr. Ardat Prahara, Mr. Raihan Fajar Awalivian, Miss Almira Hafizanti. We're gonna take a screenshot first before we start the first presenter. I think enough, yeah. I think enough because another one haven't. I think they didn't have the mirror background. Okay, 1, 2, 3. Good. Okay, thank you very much, everyone. Okay, for the next, now without delaying any further, let's start this session by listening the first presentations by Mr. Muhammad Raihan Fajar Awalivian from Telkom University, Indonesia. For Mr. Raihan, time is yours.
Can you see my screen? Is the screen seeable?
Yes.
Thank you. Let me begin. Thank you, everybody. Good morning to you. My name is
Morning.
Muhammad Fajar Olivian. I'm one of the author of this paper, the colleague Pursuanto and Siti Sada. And today's topic is going to be about optimization of aircraft flight scheduling and routing problem with multi-objective or anti-optimization. So for the introduction, during the COVID-19 pandemic, transportation became a serious concern problem. And in order to minimize the virus case, countries just because they flight as a measure to prevent virus spread. So as the virus cases start to decrease, countries started to reopen flight again with limitation determined by respective countries' government. This, however, will affect airlines that need to schedule flight efficiently due to fewer such as limitations such as flight capacity and then number of flights. So flight scheduling and aircraft routing presented two significant flight management problems and can help to efficiently schedule a flight to help with the limitation. It is necessary to research the potential of the latest swarm intelligence algorithm to be able to know the algorithm's ability later to be used to optimize these cases. So, by scheduling and aircraft routing problem itself, in order to find the optimal relationship between both of these, will need to be solved in integrated flight scheduling and aircraft routing. So, the assumption to fit with the actual situation is each flight will only be done by one flight. The departure and arrival have a flexible time range, and the travel time of a flight is a fixed time. So the formula of multi-objective fitness function that we use is to minimize the TC or total cost and maximize TP or total passenger. Total cost itself is an expense of every flight schedule in a solution can be formulated as the summary of FC or fixed cost. FC is itself is cost where it's using an aircraft, and summary of IC or CMFD. IC is idle time cost, cost where aircraft is not being used. OC is operational cost, the cost when aircraft is being used to as a flight trip, and the flight distance between the two airports. While the total passenger is a cumulative of total passenger in all flights and can be seen by the summary of MP times LR. MP itself is the maximum passenger of the aircraft, and LR is the load rate of the flight. So the dataset used was Open Sky COVID-19 Fund flight from Open Sky Network, and this offer the history of a flight during the COVID-19 pandemic, and the categorizing will be carried out as seen in the table. So this categorizing is done so that we know the optimization algorithm can work in a large, medium, and a small data group. So the method being used is called multi-objective underlying optimization, or MALO. It's an alternative technique by Abu Aliga et al. In 2020. This have been used in scheduling cases too in task scheduling. So MALO itself is combined by two algorithms. The first one is underlying optimizer, and the second one is differential evolution. The combination of ALO and DE itself is intended to balance the exploration and exploitation ability, where it helps reduce the possibility of getting the solution stuck in local search. So Mallow algorithm, the first one is to initialize the random solution in ants and antlion, and then we calculate the fitness function, and then we find the best antlions, or assume it as the optimal antlion is the solution. While the termination criteria is not reached, we look for each solution. We select a solution using roulette wheel, and we do an operator called enter random walk, and then we do operator called enter random walk effect, and then we decide the crossover, we decide the mutation, and then we calculate the fitness function and replace the solution with the best one, and then we return it the best solution. So the first one, the first operator of Mallow itself is called random walk. This operator inspired by how an ant is looking for the food using random walk. So the mechanism is to reverse the sequence of a flight so that the sequence is in reverse. The first one will be swapped with the last. The second one will be swapped with the second last, and so on. While the random walk effect is the second effect, is inspired by how when ants is looking for the food, there's always an outline to trap an ant and affect the ant's movement. So the mechanism itself is the position of antlions will be copied into the ant's position. So the ants will move towards that outline. For the crossover, is one of the operator of the DE, it's called PTL crossover. So we will select two aircraft from the sequence of a flight, and then we move that to the right and the left side, while we shift the rest towards the other side. For the mutation itself, there is two stages. The first one is called destruction. In the destruction part, flight in a flight sequence will be moved into from the XD into XR randomly. While in the construction part, the aircraft that is not being used in XR will be swapped back again into the XD by considering the fitness function of that flight sequence until all solution completed. For the result itself, Mallow has successfully increased and decreased, increase the total cost and decrease the total passenger of our flight from the small data group until the large data group by 0.75% and decrease by 4% and 20% in large data group. While we compare the model comparison in small data group, the figure suggests that Mallow struggle to keep up with the explorative ability of GA. While Mallow and Allo able to converge fast, Mallow still GA still able to defeat the solution of Mallow and Allo. However, as the data increased in the medium data group, Mallow and Allo started to improve their ability, the exploration and exploitation ability, by able to converge fast, but also find the solution fast. As the data set increase again in the large data group, Mallow and Allo show much more improvement in the exploration and exploitation, able to converge fast, and able to outperform GA solution in all iteration. This shows how Mallow's ability is much more suitable in a large data set. For the processing time, the figure suggests that GA processing time growing linear. However, as the dataset increases, Mallow started showing a much more superior time processing with a much bigger gap every time the data increases in the small and then medium and the large, the difference started to show. So for the conclusion itself, Mallow successfully increased the estimated number of passengers and decreased the total operational cost of the real-life flight schedule. Mallow got outperformed by GA in smaller data set, however, able to yield a better result when the data was increased in the medium and the large data group. have a faster processing time and converge faster compared to the other algorithm, and offer Malo an opportunity to be able to be implemented in other area with a large data input. For further research, an increase in the size of the data set and implementing in Malo in other optimization problems could further understand Malo ability in other area and in its data set. And then developing another multi-objective technique to be implemented in Malo to able to improve Malo's ability when dealing with multi-objective problems. Thank you.
Okay, thank you very much, Mr. Fajar, for your great presentation with the title Optimization of Aircraft Flights, Scheduling and Routing Problem Using Multi-Objective Unit Optimizations. Thank you very much. So now we are going to the Q&A question. Mr. Fajar takes almost 10 minutes, yeah. Almost 10 minutes. So we still have 5 minutes for the Q&A sessions. Okay, guys, for the other authors who have a question for Mr. Fajar, please ask directly or chat in the column chat column. Do you have any question, everyone? If you have any question, please write in the chat column. Mr. Rehan, we have no question for you because no one, there is no question from another outdoors. So thank you very much, Mr. Rehan, for the grateful presentation. Oh, there is one from Mr. Gegi. Yeah, Gegi Ajardiawan. The question is, what is the hardest difficulties during your research?
Thank you, Mr. Gegi and Ajardiawan.
Yeah.
There is no really hard thing to do because the optimization itself is already researched before, and we just want to know the algorithm's ability in the cases that are already researched to before. So we just implement it, and we want to know the algorithm's ability further. Thank you.
Okay. What about Mr. Gegi? Thank you, Mr. Raihan, for the answer. So there is no the hardest difficulties during doing your research, right? Because this research already, this title is already implemented before, right? Okay, thank you, Mr. Raihan, for the answer. Is there any questions? Is there any other questions? Before we continue to another presenter. Still waiting for you. We have 3 more minutes. Okay. Maybe from Mr. Eko Prasetya, maybe. Or from Mr. Kin Mount Tai from Malaysia.
Yeah.
Am I right?
Yeah. Yes, sir.
Okay. Do you have any question for Mr. Raihan?
May I know the algorithm that you use is a population-based algorithm? Is it a single population or I mean multi-population based algorithm?
It's a multi-population based algorithm.
Okay.
It's a multiple population. All right.
Okay, thank you.
Okay, thank you, Mr. King, for the questions, and thank you for Mr. Raham for the good answer. Another questions, maybe? Okay, we have 2 minutes more. No? There's no questions? Okay, we go to the next. Thank you, Mr. Rehan, for the presentations.
Thank you.
We go to the next presentation from Mr. Kin.
Yeah.
From Mr. Kin Maung Hitai from University Malaysia, Perlis, Unimap, right?
Yeah.
Malaysia. Under the title, a pairwise T-way test suite generation strategy using gravitational search algorithm.
Right.
Okay. For Mr. Kin Maung Hitai, time is yours.
Okay, let me share the screen. Hello, everyone. Can you see the screen? Can you see my screen?
Yes, we
Yes.
can, sir. Yes, we can.
Okay, thank you.
Yeah.
Hello, everyone. My name is Kim Mounty. I'm a graduate student at University Malaysia Perlis under the Faculty of Electronic Engineering Technology. On behalf of my co-authors, today I would like to present about our research topic entitled A Pairwise T-way test suite generation strategy using gravitational search algorithm. This is the outline for the topics that I'm going to be going through in today's presentation. To ensure the quality of the developed software, software testing plays a crucial role in software development lifecycle, SDLC. Several software testing techniques have been developed to produce test cases that identify faults in software systems. Multi-factor faults, also known as interaction failures, are commonly found when there is an occurrence of interactions between the input parameters and values of the system. Exhaustive testing can be used to test those multi-factor faults. However, it is impractical because of limited time and resources. Thus, a sampling testing strategy called T-way testing can be used to generate lesser test cases based on T-way interaction strength. Pairwise testing or two-way testing is a type of T-way testing strategy which emphasizes on testing interactions between any two parameters in system and the test. According to the research studies, pairwise testing can detect up to 80% of faults when testing across various SUTs. The primary objective of pairwise testing is to produce optimal test suites that covers two-way parameter interactions once at the most. Among the approaches of pairwise testing, such as algebraic, pure computational, and meta-heuristic algorithms, meta-heuristic-based strategies produce the most minimum results compared to other approaches. Such strategies include particle swarm optimization and colony optimization, cuckoo search, etc. However, T-way test data generation is an NP-hard problem, and no single algorithm can guarantee to produce optimal test size for all types of system configuration. By that motivation, in this research, we propose a new pairwise T-way strategy using gravitational search algorithm. To understand the application of pairwise testing, take a look at the example system as shown in figure 1. The security surveillance system includes 5 input parameters, which is shown on the left side. Each parameter has 5 input. Each parameter has 2 bit values or options, and the detailed system parameters and values are illustrated in table 1. If we use exhaustive testing to test this type of system, it will require 32 exhaustive list of test cases to be tested. However, in real-life system, there can have enormous amounts of parameters and values in software systems. So it is, which can lead to combinatorial explosion problems. By using pairwise testing, the exhaustive test list can be reduced up to 7 test cases. Those 7 test cases cover all required two-way parameter interactions and also saves up to 78% of testing time and cost. Among the different approaches of pairwise testing, algebraic-based strategies are the earliest developed ones. It uses algebraic functions to generate test cases. In terms of computation time, they are extremely fast, but it is designed to test only small systems. Unlike algebraic-based strategies, pure computational ones implement two types of test suite construction method, one parameter at a time, OPAT, and one test at a time, OTAT. They are deterministic-based strategies and can support testing large system configurations. However, it still struggles to generate optimal or near-optimal test suite. Finally, meta-heuristic-based strategies mimics the processes of natural phenomena, such as evolutionary algorithms, swarm intelligence, etc. Their strategies can provide most optimal solutions among all other strategies, since the strategies have stochastic behavior. However, it requires longer test generation time to get optimal results. GSA is a meta-heuristic optimization algorithm based on Newton's law of gravity and the law of motion. It has been widely applied in various fields of research due to its efficiency in solving optimization algorithm. GSA assumes a hypothetical universe consistent of population of objects attracted to each other by gravity force. Each object with its own position vector is designated as possible solutions to an optimization problem. The performance measure of each object is evaluated by mass, and mass is assigned with its fitness values. However, heavier objects also attract lighter objects in the search space. At every iteration of the algorithm, the position and velocity of each individual objects are updated and the process iterated until stopping criteria are met. This slide shows the detailed steps of GSA. After the search space initialization step, step B, steps B to G are repeated until all the termination criteria are satisfied. This slide shows the proposed framework for our strategy. It has three main stages. Stage 1, import data of SUT configuration and also initializes GSA parameters. For stage 2, our proposed strategy, PGSES, generates all pairwise parameter combinations, as can be seen on the right slide, which is AB, AC, AD, AE, and so on. Based on those combination results, the interaction tuples for all parameter generation will be generated and added to the ITL, which is interaction tuple list. And for each parameter combination, there will be 2 by 2 tuples. And the rest of the parameter combination will be iterated in the same manner. In stage 3, our strategy first generates a set of populations or test cases. And based on those test cases, the quality of each test case will be assessed by this fitness function, which is the number of interaction tuples that can be covered by the candidate test case. The test case that covers the maximum number of tuples at each iteration cycle will be selected and added to the final test suite. And the covered tuples by that test case are removed from the interaction tuple list. And the same procedure is conducted to search for test cases that covers maximum number of tuples at each iteration cycle. So this is shown for each iteration cycle as an example. When it reached to the final step, where all of the tuples have been covered from the interaction tuple list, the strategy will display final test suite, which can relate to the pairwise T-way test suite of the example system that I mentioned in previous slide. Before comparing our proposed strategy with existing strategies, the parameters of GSA are tuned first, and the table shows the tuned parameter setting used for experiment. For the experimental results, we have been divided into 2 groups. The first group compares PGSAS with existing pairwise strategies using 11 various system configurations. And for the second experiment, the values V is fixed with V equals 2 and P parameters are varied from 3 to 50. As can be seen in the first experiment, PGSAS, our proposed strategy, maintains competitive results, even though it does not outperform other strategies. In the second experiment, PGSAS mostly obtains optimal results in all cases, except the last system configuration with 50 parameters. To conclude, this research proposed a new pairwise T-way strategy based on gravitational search algorithm. According to the benchmarking experiment, PGSES often obtains competitive results in most cases. However, like most other algorithms, GSA suffers from premature convergence. For that reason, we are planning to hybridize our current proposed strategy with other optimization algorithm to improve the current performance. We are also working to extend the strategy support to be able to support other types of T-way strategies such as uniform and variable strength testing. These are the key references that we use in our research work. Thank you for listening.
Thank you very much for Mr. Kim for the presentation. Okay, now Mr. Kim takes almost 9 minutes. 9 minutes, almost 9 minutes. So we still have 6 minutes for the Q&A questions. Okay, Q&A sessions, I mean. So here for the participants, I mean the another outdoor. If you have any question for Mr. Kim Maung Tai, please ask him. Thank you. You can write in your chat column. Maybe. Okay, Mr. Kim is waiting for you guys. Come on. This is a great research. This experimental research, Mr.
Yeah, right. Experimental research.
Experimental research. Okay. Is there any question for Mr. Kim? Mrs. Prabhat, Mr. Prabhat, Paninder, do you have any questions? Oh, from Mr. Raihan.
All right.
Okay.
Thank you for the question.
Okay. Let me first read the question. How do you tune some of the parameters such as the population of the experiment? Okay, please, time is yours, Mr. Kim.
Okay, so the gravitational search algorithm have been applied in various fields of research. So each published strategies have been tuned based on their optimization problem. So our research, which is T-way testing, is also considered as an optimization problem. So we are also required to tune parameters in relation to our optimization problem. So as a baseline, we refer to some published strategies, the tune parameters, and based on that baseline tune parameters, we start tuning parameters. So we have 4 parameters. We selected 4 parameters, and we tuned it using different range of values. And after that, we take reverse experiment. At first we tune the parameters with fixed values. So we have 4 parameters. So we fix, let's say population and total iteration size, we fix the values, and we tune values to the rest of the, we have G0 and other 2 parameters, and we tune these values with different range of values. And we conduct reverse experiment. Reverse means the rest G0 and alpha will be fixed. The values for G0 and alpha will be fixed, and the population size and total iteration will be tuned with different range of values. So after that, we select which best combination of parameter values give the best result for our experiment. I hope this answered the question.
Wow, that's a wonderful answer, Mr. Kim. Thank you, Mr. Kim. So, thank you for the answer. So there is another question from Mr. Ardat Prahara Setyan. The question is, in the future, where can your research be developed? Thank you. Please.
Yeah, thank you for the question. Currently, our research work is still experimental work. So this one, if it's to be developed in a real, because this research field which is known as T-way testing or combinatorial field, is a new research field, and which complements the existing software testing techniques that is currently using in industry. So in the future, it will be very helpful to detect multi-factor force, because in software testing, the force can be found based on single parameter, single input function, or sometimes the fault can be found when there is an interaction between the input parameters, input functions and values. So for this type of testing, T-way testing will be very effective in detecting multi-factor faults. For single factor faults, other strategies are preferable. So we focus on testing multi-factor faults.
Okay.
I hope this answers the question.
Mr. Adat, what about you? Is this answer your questions? And thank you, Mr. King, because our time is up.
Yeah. Okay, thank you.
Okay, thank you very much for your great presentations. We continue to the next presenter from Mr. Ahazuraida, Mrs. Ahazuraida, from Polytechnic Elektronika Negeri Surabaya, Indonesia, with the title Short-Term Electrical Load Prediction Using ENN Back Propagations. Mrs. Almira, Mr. Almira Zuhraida, time is yours.
Okay, thank you for time.
Yeah.
Let me share the screen.
Yeah, please.
Okay. Is the screen seen?
Yes, it can be seen. Thank you.
Okay. Hello, everyone. Good morning.
Morning.
My name is Amira Zuraida. In this occasion, I would like to present about short-term electrical prediction using ENN backpropagation. And I'll tell you why we need to know this and what it's all about. Okay. Electrical energy is a vital requirement of citizens in Indonesia, and everyone has different use of electricity. So, the total of power consumption is fluctuating day by day. PLN, as Indonesian electric company, is required to provide electricity needs. In determining electricity supply, it requires future load data by short-term prediction. Based on many previous researchers, artificial neural network backpropagation is the recommended method for prediction. The NN architecture is one important rule of successful implementation, and one of them is the number of hidden layers. The researchers usually use trial and error to choose the best architecture, which take longer time. So, we observe the effect of the number of hidden layers in ENN backpropagation for several combinations. Then, the sequence of this research. First, determining ENN architecture, and the second, architecture initialization in program. The third, build the ENN network, then carry out the learning process. After that, the result of learning process by hidden layer combination is compared. After that, choose the best network from hidden layer combination. And to prove the best network before, it is tested by another data. And from testing process, it will compare to actual load and PLN prediction that use coefficient method. And for the last is analysis and conclusion. The slide shows the power consumption data of PLN of West Kalimantan region kampus sector from 25th of April to 22nd of May. This data is used for this research. And from the previous chart, we take the ANN data. The first learning process use first week, second week, and third week. And for first input is today's load data per hour. The second input is today's code, 1 for Monday, 2 for Tuesday, 3 for Wednesday, 4 for Thursday, 5 for Friday, 6 for Saturday, and 7 for Sunday. The third input is clock code from 0 to 23. And the output is tomorrow's hourly load data. And for testing process, use fourth week data. And the NN architecture that used in this research, the input layer is 3 neurons, the output layer is 1 neuron, and using Tansig activation function, and the learning rate is 0.8, and the error goal less than 16,000. The maximum iteration or epoch is 5,000, and using Riefenberg-Marquardt training function. So the result of learning process is shown in the table. And this is one hidden layer is compared to 2 hidden layers for same neurons and different number of neurons. And the performance is looked from the epoch, the mean square error or MSE, and convergent or not yet converging. So from the previous table, we can know that 2 hidden layers are better than 1 hidden layer for same total number of neurons, because 1 hidden layer need more neurons to reach the convergence. And for 2 hidden layers, more neurons in first layer is better than more neurons in second layer, because more neurons in first layer has smaller MSE than more neurons in second layer. And for 2 hidden layers, same number of each layer is better than different number of each layer, because same number of each layer has the smallest MSE, at least epoch, and the one only reach convergence. So the best architecture is 2 hidden layers with 10 neurons of each layer. And after we got the best network, it is tested by for big data. Then the ANN compared to PLN prediction and actual load. And the slide shows the comparison on 17th of May and 18th of May. And we can know from the chart that ANN look closer to actual load than PLN prediction. But ANN prediction still has far error in 18 to 19 o'clock for 17th of May and 19 o'clock to in 18th of May. And then in 19th of May and 20th of May, we can see that ANN prediction look far from actual load, and PLN prediction look closer to actual load. And ANN prediction has majority error in several clock. And then the comparison in 21st of May and 22nd of May. In both of the charts, we can see the ANN is closer to actual load than PLN prediction. But on 21st of May, the ANN prediction has far error in 23 clock. And for the last, in 23 of May, the NN prediction and PLN prediction is close to actual load, but still has far error in 17 to 18 log. And PLN prediction mean here, PLN use coefficient method for prediction, which obtain the specific coefficient toward the input to determine the output. And from all of the charts, we can know that NN prediction and PLN prediction has some errors for several hours. So to ensure the quantity of error, we take the average error from per hour to get the average of daily error that shows in the table. And we calculate the average of daily error to get the weekly error. And then the NN error is compared to PLN error. And from the previous table, we can know that NN method has a smaller daily average error than the PLN method on Monday, Tuesday, Wednesday, and Thursday. And the PLN method has a smaller daily average error than the NN method on Friday, Saturday, and Sunday. But on Friday, just small deviation. And the NN method has a smaller weekly average error than the PLN method. So the conclusion is the best NN architecture is 2 hidden layers with 10 neurons each layer. And NN backpropagation method has better daily prediction in weekdays than coefficient method. Then NN backpropagation method has better weekly prediction than PLN method. So thank you for your nice attention. If you have any question, it will be nice.
Okay, thank you, Mrs. Almira Zuhraida from Politeknik Elektronika Negeri Surabaya, Indonesia, with the title Short-Term Electrical Load Prediction using ENN Backpropagations. Thank you very much for your great presentation. If you have any question, guys, please write in your chat column. Okay, from Mr. Eko Prasetyo. Yeah, the question is from Mr. Eko Prasetyo. He asks that how do you justify the not convergence?
Okay, thank you for Mr. Eko Prasetyo for the question. How I justify the not convergence? That I show I has target error less than 0.016. Not convergence means it doesn't reach the target error, and convergence means it reach the target error. I hope this will answer your question.
Mr. Eko Prasetyo? Thank you. Okay. Thank you, Mrs. Almira. Okay, guys, do you have any other question? We still have 2 minutes more for this session, Q&A sessions. Okay, we're still waiting. No? There's no questions? There's no other questions. Cool. So thank you very much for Mrs. Almira Habizanti for the presentation of your paper. So we continue to the next presenter. The next presenter is from this one, Ardat Prahara Setian. with the title Predicting Visual Theft with Backpropagation Algorithm in East Java Regional Police. Mr. Adat Prahara Sethi, November, Indonesia. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Allow me thank you for the time given to me, and the second time let me introduce myself. My name is Ardat Prahara Setyan, Department of Electrical Engineering, ITS Surabaya. Occasion I will present a paper entitled Predicting Vehicle Theft with Backpropagation Algorithm in East Java Regional Police. Here is the outline for our presentation. The first is the introduction, the second is research methodology, and next result and discussion. Finally, our conclusion. Here is several background due to our research that we will like to explain before going. Vehicle theft in East Java is a crime that causes unrest and anxiety in the public. Theft still threatens every motor vehicle owner. According to data from the Central Statistic Agency of East Java Province, the number of motor vehicle theft in the last 3 years, 2017 to 2019, had fluctuated. It is due to many factors, including educational, economic, environmental, low environment, global development, individual factor. So it is necessary to do the research in the urgency, in the real problem. The problem of controlling crime related to vehicle theft by the East Java Regional Police is prevention strategy to reduce vehicle theft. We present an intelligent system that aims to predict location prone to vehicle theft using the backpropagation artificial neural network algorithm and graphical user interface to visualize the prediction result. The flowchart is shown above by doing data processing. The training data used is the result, the incident of theft from the East Java Regional Police from 2015 to 2019. Table city is the coding of the area of incident category. Surabaya is code 1, Port of Tanjung Perak is code 2, and so on. Data on the location of incident is also converted into numeric form. Table vehicle wheel, table vehicle brand. The training data used were 4,546 row of data. The testing data and validation data used were 974 row of data. Table target location of event. In this research, location prone to vehicle theft were prediction using the backpropagation ANN method. The backpropagation architectural model of this research is as follows. Figure backpropagation network architecture model explain that the input layer variable has 7 nodes, the hidden layer has 10 nodes, and output layer has 6 nodes. The total parameter of this architectural model are 130, white namely 70 from the input layer to the hidden layer, 60 from the hidden layer to the output layer, where the training process will produce which will be tested. Yes, this is the result and discussion. The amount of validation and test data was also determined before NN was trained to be 15% for a sample, where 70% was used on the training sample. The best result given from the initial NN training and validation is obtained at 10 hidden layer due to the slack cross entropy increase after 10 hidden layer to 20 and so on. Pattern recognition based NN can minimize cross entropy result and place it in good classification because a lower value in considered better. In addition, value of zero mean, there is no error, while the value of percent error indicates a wrong classification of the sample fraction. Thus, zero mean there is no classification error, 100% the maximum classification error. The total error divided into 20 bin as observed in the number of vertical bar located and the x-axis where the number of sample from the dataset located in S bin is percent on the y-axis. Here are 4 metrics that contain the result for every step as shown. The reservoir operating characteristic curve in figure is based on the value between the false positive rate and the true positive rate obtained from the confusion metric, and the result shows that the performance of the NN system in classifying target is correct. The tabel testing use telling data input a target office year testing result correct. Prediction application implementation conclusion. Result objective, the result concludes the prediction of location prone to vehicle theft using the NN propagation algorithm. Analysis finding 1, the smallest training cross entropy value is 5180 with an error value of 0. The smallest validation cross entropy value is 40.1697 with an error value of 0. And the smallest cross entropy testing value is 14.705 with an error value 0. Analysis finding 2 from a several experiment neuron with architectural model 7-10-6 get optimal accuracy result. Analysis finding 3, the reduction of attribute in the money category of training data input result in reduction in the accuracy of prediction result. Research contribution, the study result with the addition of graphics Visual user interface, I can visualize the result prediction that will impact the IC which officer monitor vulnerability location for vehicle. Recommendation for further research, and it is hoped that further research on prediction using method such as fuzzy logic, support vector machine, Bayesian network, fault tree analysis, and ethic attribute such as layer, neuron can be considered to compare with method the most optimal. Thank you for attention.
Thank you, Mr. Ardat Prahara from Institut Teknologi 10 November. That's you did great presentations. And now we only have one question actually, yeah, because our time is limited. Yeah. Do you have any question? Only one question for you.
Yeah, Mr. Ardat, I have a question for you.
Okay, please, Mr. Ferry.
Yeah. What is the reason that you use date, month, and year for your perceptron in artificial neural network? And what is the conclusion for that you have resulted the model has a lower errors in your models? I think that is my question.
Okay, do you get it, Mr. Ardat?
Yes, all right. The
Okay,
problem
please.
of controlling crime rate related to vehicle theft by the East Java Regional Police is a prevention strategy to reduce vehicle theft. This algorithm is good for training. It is IC and sample iterate algorithm that usually work well even with complex data. Unlike other learning algorithms, such as Bayesian learning, this algorithm has good computational properties when handling large-scale data.
Okay. Enough, Mr. Ardat?
Pattern recognition based and can minimize cross entropy result and place it in a good classification because a lower value is considered better. In additional, a value of 0 means there is no error, while the value of 0 error indication wrong classification of the sample caption plus 0 means there is no classification error, while 100% the maximum classification error. In addition, different result from the training carried out at different time due to variance in initial condition and sampling. Thank you, Mario.
Okay, thank you, Mr. Ardat, for the answer, and thank you, Mr. Ferry, for the questions. We'll continue to the next presenter, which is from Mr. Prabodh Paninder from New York University. Am I right? Yeah, from New York University, under the title Assessment of Artificial Intelligence Technique for Automated Remote Classification of Cardiac Arrhythmia using Instantaneous Heart Rates. Yeah. Mr. Prabodh Paninder, time is yours.
Can you see my screen?
Yeah, we already seen your screens.
Okay, good. So good morning, everyone. It's
Morning.
9 o'clock in New York in the evening.
Oh,
so
yeah.
That's okay.
Okay.
So I'll try to do my best.
Okay, you will do your best.
Okay. Yes.
Please.
So yes. So in this paper, we are basically we basically develop different AI algorithms to classify cardiac arrhythmia in real time. And we basically calculated the accuracy, sensitivity, specificity, and all these performance characteristics of all these algorithms and evaluated the performances, compared them with each other. And the importance of the study is we described an approach that can process the raw data streaming from the wireless health trackers such as Fitbit, and we can detect the serious health conditions in real time and also alert the vulnerable individuals so that they can act upon it and avoid the consequences, improve the overall quality of life. Oops, sorry. So cardiac arrhythmia is a serious health condition that can be described as a presence of abnormal singular heartbeat, or it can be a irregular heartbeats, or any cardiac rhythm that diverges from the normal sinus rhythm. 4 million adults in the US suffer from some form of arrhythmia, costing more than 65 billion a year. There are several types of arrhythmia, such as tachycardia, bradycardia, ventricular fibrillation. Some of these arrhythmia can cause sudden cardiac events or even deaths if they are not diagnosed properly and treated properly. Whereas other arrhythmia may not be life-threatening, but they may need medical attention for avoiding serious health risks. Typically, the physicians diagnose the arrhythmia through long-term ECG, like 24-hour Holter recorder, that essentially reflects the electrical activity of the heart. A minor change in the ECG dynamics can be indication of the heart's ability to circulate the blood that can lead to chest pain, breathing shortness, or any other fatal events. Variation from this normal sinus rhythm can be, it requires a lot of effort, manual effort, time commitment, and a lot of cost is associated with it. So, and also the manual diagnosis increases the risk of false negative assessments, and it has only 90% sensitivity and 70% specificity. So a lot of vulnerable individuals still are undiagnosed or undertreated because of all these constraints. And they may suffer the fatal consequences of it. So therefore, the computer-aided diagnosis (CAD) of arrhythmia is necessary for long-term continuous monitoring. So usually, every one of us, we have these Fitbits, Garmin, and these devices are continuously tracking the physiological data, such as heart rate, sleep behavior, step counts, and stuff. And all this data is saved to a cloud database. All these companies also have an API for developers and the researchers to access the user's data with the user's permission to develop healthcare applications. And this technology has been used, in multiple disciplines to diagnose, collect, and treatment monitoring. So in this study, we are basically trying to utilize this off-the-shelf health tracker technology integrated with AI for automated remote diagnosis of arrhythmia. So we use two databases, MIT-BIH arrhythmia database and the normal sinus rhythm database, which are provided by the Physionet. The MIT arrhythmia database has 48 30 minutes long sections of ECG recordings. 60% of the patients during these recordings were under treatment in the hospital, whereas 40% patients were going through the treatment, but they were not admitted to the hospital. The other database, which is the MIT normal sinus rhythm database, it comprised long-term ECG recordings of 18 subjects, and they did not show any signs of significant arrhythmias. So the instantaneous heart rates can be obtained from the ECG signal by measuring the RR interval between the two beats using this formula. So in this study, we basically used the Physionet waveform database toolkit to convert all the ECG records into heart rates. And we took all those data and we split it into overlapping sequences of 128 heartbeats. So now these sequences were labeled as 1 if it contains 1 or more beats that were classified or annotated as arrhythmia by the MIT lab. And if there is no annotation of arrhythmia, then they were labeled as normal sequences as 0. All the other sequences from the normal sinus rhythm database were labeled as 0 because they were normal. So this MIT arrhythmia database had a lot of other annotations such as A for atrial, S for supraventricular and stuff. So we basically, did a lot of interpretation of the annotations and then classified all the sequences. This database yielded 80,000 arrhythmia sequences and 23,000 normal sequences. So there was an imbalance of, there were too many arrhythmia sequences and there were very less normal sequences. So in order to avoid the biases or in order to maintain the balance between the arrhythmia and the normal sequences, we added 57,000 normal sequences from the MIT normal sinus rhythm database. So now there was basically 50% distribution and there was no bias. Also, the addition of the normal sequences from the MIT normal sinus rhythm database ensured the learning from the normal heart rhythms of the individuals without the arrhythmia. So the models also learned from the people who are just normal, they have no arrhythmia. And this K-means clustering algorithm basically shows that the diagram shows that the centroids of arrhythmia and the normal are distant from each other, basically shows that there's a significant distinction between the sequences with arrhythmia and the normal sinus rhythm. So there is also it also implies that there is a underlying dependence of the sequences on the arrhythmia. So we use the NYU supercomputer cluster to train and test the algorithms. We have this, this is the configuration of our supercomputer system. We use 5-fold cross-validation strategy to ensure that each fold was a representative of the balance of the complete data set and evaluated the model performances. So we tested a lot of models, and these are the specifications of the algorithms. You can find the details of the specifications in the paper. In the interest of the time, I'll skip the details, but essentially we tested the logistic regression, AdaBoost, naive Bayes, Gaussian naive Bayes, KNN, decision tree, random forest, SVM, RBF, and we also trained the deep learning models, which are basically the LSTM and the BiLSTM approaches. So these are the results, and we, this basically table gives you the accuracy, recall, F1 score, and AUC, area under the curve, precision, and all this for all the models for the same data set. And we actually categorized, we also did the Friedman test with alpha is equal to 0.005 to see if there is a statistically significant performance difference for the classification of arrhythmia with all these algorithms. I'll go back to the results again, but what in this study, I want to make sure that I've covered this topic, and the main focus is basically to generalize the approach so that we can detect a lot of other conditions, not just arrhythmia. So this is a flow map where a user or a patient has a health tracker of the individual, and they sync that health tracker with the mobile device, and all the data goes to the cloud. The company or the manufacturer basically gives you, pings you that, hey, we have a new data available. So you fetch that from their server, and then you split that into overlapping sequences. Those sequences are fed to the AI models, AI model will calculate the probability if this sequence has a arrhythmia or not, or AFib or not, and it will report you. And then you can, based on your risk threshold, you can notify the individual, hey, we observed some disturbing, we observed the trends of arrhythmia, and maybe you need to go and take care of it. So, you can actually use multiple models. So one sequence can go to multiple models, and then you get the output from multiple models, and then you compare it to make sure that you have more reliability of the output. All these models were around 4 MB in size, so you can actually integrate those into your devices. So you don't have to even send the data to the cloud and get process it on the server and do that. You can actually process all these outputs in your device so that the user can get the instant notification. So to conclude, we basically found that among all the AI approaches, the BiLSTM approach, the deep learning approach, received the highest test win rank. So it performed, it showed the remarkable accuracy of 96.74%, very good recall, F1 score, AUC, and the specificity in comparison to all the other models. In the future, we are planning to hyper-tune these models for better performance by incorporating multiple other features for personalizing the medical evaluations. And the reason we think that the BiLSTM or the deep learning approach did better than the other ones is because that's the nature of the AI algorithm, the deep learning algorithm, that it does very well with the time series sequential data set. And of course, there is no, there is no need for the information reduction through feature extraction in deep learning. And of course, I think finally, I want to mention that the approach we described in this study can be used to detect other types of health conditions in real time and improve the quality of life, reduce the costs associated with the healthcare with off-the-shelf technology, which is already available with the health trackers, and you don't have to go to a doctor or to detect AFib, which is a very paroxysmal condition. So that's it. Thank you very much, and I'd like to take some questions.
Okay, thank you very much, Mr. Prabhat, for your presentations. Yes, you have any question for Mr. Prabhat? Paninder. If you have any question, please ask Mr. Prabhat. Okay, we have 2 minutes left. 2 minutes left.
I'm here.
Okay.
I'm hungry, but I'm here.
Okay, that's very simple. 2 minutes. Okay, do you have any question, guys? Maybe from Mr. Gegi, maybe, or Mrs. Almira, Mr. Rehan, maybe. If you have no questions, Mr. Prabhat can looking for something to eat.
Okay, sure. Okay. Have a good day, everyone.
Okay, nothing, Mr. Thank you very much for your very nice presentations. Okay, we continue to the next presentation, which is from Mr. Novin Kankar, August Al-Hassa. Nothing. Is there any Mr. Novinkan here? Are you here, Mr. Novinkan? Novinkan Kar August Al-Hassa. There is no Mr. Novinkan. So we continue to Mr. Ferry Wahyuwibowo. Mr. Ferry Wahyuwibowo, are you here?
Okay, I'm here.
Okay, Mr. Ferry Wahyuwibowo is from Universitas Amikom Yogyakarta, Indonesia, under the title Multi-Classification of alcohols using quartz crystal microbalance sensor based on artificial neural network single layer perceptron. Mr. Ferry Wahyuwibowo, time is yours.
Thank
You
you.
have 15 minutes.
Okay, thank you for
Yeah.
the chance for me to present my presentation with entitled of my paper, multi-classification of alcohol using quartz crystal microbalance sensors based on artificial neural network single layer perceptron. Okay. The outlines of my presentation is introduction, related works, method, result and discussion, and conclusion. For the introduction, we know that sensor can read the condition around of the environment. It needs some aspects that should be considered in this measurement, which are accuracy and measuring. For the measuring, to know that the sensor is in good condition to measure the around of the environment, we use the calibration with the other device, and another aspect is common from the analytical device. Meanwhile, the accuracy, we need to know that the sensor can produce read condition with the standard measurement. There are some devices that should be considered in sensor read the around of environments, which are analog signal, amplifier, and processing, which are the processing that could be used FPGA, programmable gate arrays, or microcontrollers, or microcomputer like Raspberry Pi, Banana Pi, and etc. And then in this case, we know the biosensors, an analytical device consisting of bioreceptor and physicochemical transducers, which is very significant device in high sensitivity. We know that this transducer, its instrument primarily, the biosensors commonly consist of nanostructured electrodes and nanoparticles. And then it needs automated process to measure, to read the condition of the analytical or material. The advantages for using a biosensor is rapid diagnosis, reduces time, and effective treatment. One type of pseudoelectric biosensor is quartz crystal microbalance, or QCM sensors. The function of QCM is very large. Some of the function are taste sensor. It's determining levels of chemicals as the human tongue. And the smell sensors, it's like how to detect gases in around of the environments. The capabilities of the QCM sensors based on the frequency characteristic resulting from the setting of the layer, which are many layers for these biosensors, and then low performance due to non-uniform distribution of mass sensitivity. And other capabilities of the sensors is uniform mass sensitivity distribution of QCM source, high performance, and can be improved more. So for this case, many researchers use this sensor for detecting many analytics. And then the implementation of these sensors are measuring bacterial growth in liquid media, and then detecting bovine serum albumin, or BSA, protein at low concentrations, detecting plasmin, or PLA, in milk using beta-casein,
and then detecting gases that use a specific setting and configuration. For example, ZNSN OH6, which is modified KCM sensor, can be identify the concentration of 3 different gases of chlorine, carbon monoxide, and oxygen. The aims of my papers is to model multiple classification of experimental results from dataset of KCM sensor types. In this case, we use KCM3, KCM6, KCM7, and KCM10, and KCM12. The modeling uses an artificial neural network, or ENN, but in this case, our paper using single layer perceptron, which is no hidden layer in these models. The evaluation of the NN and SLP model in the multi-classification of alcohol from this KCM sensor uses the error values of the training and test model. In this case, we are using root mean squared errors to evaluate our model. Related works from this paper is some research have been emerged in this case, like other system using KCM array sensor, which and to identify volatile organic compounds of VOCs, methanol, ethanol, chloroform, benzene, and acetone for determining blood glucose levels in human, and other research using KCM sensor to determine the gas mixture using ENN. It has it gained 84% until 94% in the detection of gas mixture of ethanol, acetone, ethanol, trichloroethylene, and acetono trichloroethylene. And the other research is about the enos based on KCM, which is classifying multiple Chinese liqueurs using INN. From this research, it gained that ENN is superior than multidimensional scaling support vector machine using classification method. It's around 93%. The method that we use in our papers dataset 5 sensors, and then measuring different alcohol for multi-classification, which are 1 octanol, 1 propanol, 2 butanol, 2 propanol, and 1 isobutanol, with ratio air and gas concentration in milliliters, as seen in this slide. We got from the correlation matrix, KCM3, we use training and testing ratio is about 70 and 30 for making the prediction of the sensor rate of the gases. And then the model we use using INN SLP, like this model, and we use also for 1-hot encoding for making multi-classification for alcohol types. And perceptron training rule we use as shown in the slide in my presentation. And then the result and discussion, prediction result from the INN SLP model with learning rate 0.01 and 5,000 epoch. From this case, we have KCM sensor 3 is the best accuracy for prediction, which for the testing prediction, we have 100% for accuracy for this case, while the worst prediction accuracy is gotten for KCM12 sensors. And then prediction result from the INN SLP model with learning rate 0.1 and the same epoch, 5,000, we get the KCM6 is the best accuracy. But there are some not until worse case for prediction accuracy, not like the learning rate on 0.01. The conclusion of my paper, the NNSLP model in this paper has successfully predicted the multi-classification of alcohol types. And then the categorization of variables for multi-classification in this paper uses the principle of one-hot encoding. The best prediction accuracy results from the model testing using 500 epochs, 5,000 epoch for a learning rate of 0.01 on the KCM3 sensor, while the learning rate of 0.1 on the KCM6 sensor. And then the future work for this work is to classify the result obtained from sensor arrays using this proposed model. I think that is enough for my presentation. Thank you for Mr. Istiwanga.
Okay, thank you, Mr. Very well for great presentations, very well presentations. Okay, now we're gonna go to the next session, which is Q&A sessions. If you have, guys, if you have any question for Mr. Ferry Wahyuwibowo, time is yours. Okay, this one from Mr. Eko Prasetyo. The first result, I think actually for KCM to get the worst performance, why do you choose SLP, not the others such as multi-layer perceptron or even deep learning that usually obtain better result? Mr. Ferry, time is yours.
In this case, in my my experimental is to know how which one of the sensor KCM that has a good accuracy for to sensing the gases. And for the first performance, we get the learning rate on KCM3 is the best than the other sensors. While the learning rate for the learning rate of 0.1, we got the KCM6 sensor is the best than others. In this case, we know that some variables that we use in experimental, we use some data set, we get some comparison between other sensing in KCM, because in KCM can be modified for the layer. So we know that KCM3 is the best for learning rate on 0.001. And for other case, for the learning rate on 0.1, we get the KCM6 sensor is the best. That is the end of my works in this experiment. I think that's enough for.
You satisfy Mr. Eko Prasetyo from the Mr. Ferry's answer?
Okay, thank you.
Okay, that's good. Thank you, Mr. Ferry, for the answers. Do you have any other questions? No? I have no question for Mr. Ferry. Oh, there is. From Mr. Ardat. Why take the theme? Why use the method? Why do you take this title? I mean, and why do you use this method?
Okay, this is my research in detecting some gases from the mouth. In Indonesia, we know the genus. Yeah, we know the genus. Genus is from. We know that it can smell gases from our breath, and it can detect what kind of disease that in human. From this case, if we know that the sensor can be sensing the gases that exhaust from our mouth, it can be detecting some disease from human. from the patient and the doctor can diagnose what is the best treatment for the patient. I think that is for future works. We will to using it for sensor arrays. Yeah, using this model, we know that KCM3 is the best for learning rate for 0.001 and the KCM6 sensor is for learning rate 0.1. It's okay, and we develop it for the case for making some sensor arrays in my proposed model. I think that is my answer.
That's excellent. Thank you very much, Mr. Ferry. Is there any other question? I think we have no question. Okay, we'll continue to the next presenter, which is from Mr. Wait a minute. From Mr. Taraknat. Mr. Taraknat from ICFA University, Jharkhand, India. Are you here? Mr. Jarahnan? No? Okay, we go to Mr. Jarahnan, are you here? With the title FinTech Empower Prediction of Stock Market Index using Artificial Neural Network. Mr. Tahna? No, nothing. Okay, we'll continue to the next presenter. It is from Abdul Raqib Ahmadi Al-Hammadi. Mr. Abdul Raqib Al-Hammadi. Yeah.
Yes,
yeah.
can you hear me?
Okay, wait a minute. From Faculty of Engineering, Multimedia University, Malaysia, with the title MOS Prediction for Mobile Broadband Networks using Bayesian Artificial Intelligence. Okay, Mr. Abdul Raqib Al-Hammadi, time is yours. Mr. Abdul Raqib, can you please turn on the camera because I will screenshot. I will take a picture.
I got a problem with the camera. I couldn't settle it down. There is a problem.
Oh, there is a problem. Oh, there is a problem with your camera actually.
Yeah. How about this? The voice is very clear.
There is some trouble actually. Please try again.
This problem this morning. I don't know what's clear. Me, it should be fine.
Okay, but that's good. That's good enough. The voice is good enough actually.
Okay. So, hello everyone and very good morning to everyone. So, I'm Abdul Raqib. I'm a research assistant from College of Engineering at Selatan University in Oman. So I'm going to present my paper titled "Most Prediction for Mobile Broadband for Using Gazing and Artificial." So I will give a brief on the mobile broadband. So the mobile broadband network and very high speed. So and also important things in mobile broadband, the network operators need to monitor their network performance and to improve the quality of services and also the quality of experience. So coming soon, the 5G networks and also provide enhanced and supporting very high speed and video streaming with very low latency. So this network need to be improved further and also to evaluate the user experience and quality of services to improve the network in 5G. So one of the metrics that can the network operators need to investigate is the mean opinion score, which is referred to MOS. So the most metric used to measure the quality of the system on the network performance and quality of experience. So the International Telecommunication Union provide 3 different calculation of MOS, or the mean opinion score, in order to improve the network performance. So the first one is the subjective test, or the subjective video MOS. This calculation can be done in the laboratory test based on the lab test. So the score of the mean opinion rate is from 1 to 5 to investigate the performance of the network. So the second one is the objective VMOS. The objective VMOS depends on the objective model, which is on the algorithmic model that can be investigated from the system itself. So last one is the VMOS based on the planning model or the proposed model that can predict of the minimum opinion rate. So this one depends on the video test in library. So in our proposed model, based on the, so we have here in the shows the consist of 7 nodes. So as you can see here, the main nodes shaded on with the gray color. So the predicted MOS here depends on the 3 first nodes, which are the stalling node and also the quality node, which depends on the bit rate of the video and latency round trip time. So as we can see from the figures here, we have B11, B12. This is the initial values that can use to burn on the sampling, because the Bayesian network depends on the gap sampling, which generates sampling to predict the this one using the MCMC, the simulation that can generate some different samples and then eventually predict the MOS rate. So and also we can see here from the figure, this figure shows the video end, and from the video end we can see the details of the or the database that can use in our proposed model. This is the database. So the database to the proposed model, the Bayesian network, and then make the prediction of the MOS rate. So and the table 1 shows the relationship between the MOS value and also user satisfaction as from 0 to 5, and give the quality of the video rate from 0 to 5 based on the user experience. So table 2 shows the parameters for the prediction of the model. So in this model we use the burn-in samples is around 10,000, and also the number of iterations is 100,000 to generate more samples and to improve the prediction of the MOS rate. So the results here, the figure 4 shows the prediction MOS versus the number of iteration. So the figure 4a shows the sampling history of generating the posterior distribution from the unknown MOS rate. So as we can see figure 4a shows the all generating samplings is bounded between 3 and 4. So this is the predicted, because the actual sampling, the actual Morse rate here is 3.6. As we can see here from this figure, the genetic samplings from between the 4 and 3 and 4. In figure 4P shows the sampling tracing for 10,000 samples. As we can see here, the samples is give the average for in 3.5 as the Morse rate, which is close to the actual value. The value here is 3.6. So the also the figure 5 shows the kernel density, the predicted Morse. As we can see from the kernel density here, the Morse generated some most close values to the actual value is between 3.3 and 3.84. So this is the region or the area that can generate more samples. In the figure 6 shows the production Morse visualization for the box, but for the box plot. Here we can see here the figure 6a shows the minimum value is around 3.2 and the maximum is 3.85 with the average value of 3.54. So in the figure 6b shows the density stripe. It shows where the generated samples bounded in which area. So we can see here the dark area here referred to the figure 5, which is the kernel density. So more samples generated in this dark area. So almost the average of the Morse rate between 3.3 and 3.8. So and the figure 7 shows the different or the comparison between the actual Morse, the actual value, and also the estimated value of Morse. And the actual value in the blue color and the estimated value in the orange color. As we can see the error here in the gray color. So the Morse values examined for 10 selected data. So as we can see here, the error is average on the 0.55. So in figure 8, figure 8A shows the histogram of the frequency versus the errors. As we can see here, the most error generated between 0.38 and 0.57. So figure 8B shows the absolute error here, the absolute error with the minimum 0.235 and the maximum 0.84 with the average of 0.55. So this figure 9 shows the mean square error versus the grouping class. So we have here 5 group classes. So we have ungroup, which examine the selected data one by one. So the others group, we group all the data in 8 group, and the second for 4 groups, and group also the data for 2 groups, and only 1 group to investigate the mean square error. As we can see here, the mean square error is for all group classes estimated on I think 3.35, which overall the average of the group classes. So the conclusion, this paper proposes a Bayesian network based on the probabilistic graphical model to predict the Morse for the quality of MBB surfaces, and also the Morse has been predicted utilizing the video streaming over the 3G and 4G networks, and give a high prediction with the mean square error of 0.34, and also demonstrate the accuracy rate of 86% with the high and robust performance design. In the future, the proposed model can be further extended to include several services such as the web browsing and also the video streaming with multiple resolution, and also can be investigated further for different databases for different mobile network providers. I think that's all. Thanks for your listening. Any question?
Okay, thank you very much, Mr. Abdul, for the very well presentations. Okay, is there any question for Mr. Abdul Rakib Al-Hamadi from what he already presented today? From Mr. Prabhat, maybe? Do you have any question for Mr. Abdul Rakib? Or Mr. Kin? Do you have any question? Okay. There is no question, Mr. Abdul Rakib, for this is for you.
Okay, thank you.
Thank you, Mr. Rakib, for your nice presentations. Okay, actually for this session, for the presenter in this session, in this morning session, is already, it's nothing more. So we need one more presenter from the afternoon session, which is everyone from afternoon session. It's like Mr. Eko Prasetyo, Ban Ali, or Gigi. Anyone who ready to present in this morning, please? Oh, Mr. Ardat, Mr. Abdul Rakib, there is one question from Mr. Ardat.
Yes.
Yeah, the comparison with other method.
Actually, in the first stage, we use the Bayesian network with some different categories of testing data. So we not other models. So maybe in the second model or second stage, we are going to get the proposed model with the others models.
Okay. Okay, thank you for the answer. And there is another question here. What was from Mr. Prabhat? Yeah, Mr. Prabhat. What was the performance of your approach with other approaches by other researchers?
As I mentioned in the first question, so for our proposed accuracy is 80% with roughly 3.34, but we haven't compared the proposed with others models. So in the second stage, we are going to compare our proposed with different models, so to investigate further is our proposed is robust enough or not.
That's a good answer. Thank you very much, Mr. Abdul Rakib. Is there any other question? No? No? Okay, for the sessions 2 in afternoon, who ready to present today, this morning? Mr. Eko, do you ready to present today? Are you ready? Or Mr. Abdul Azam, maybe? Are you ready to present in this morning? If you're ready, please, because we still have 20 minutes. Yes, ready this afternoon. Oh, it's not this morning, Mr. Eko. If you're ready this morning, you can present this morning. Because we still have 20 minutes. Mr. Gegi Ajrian Diawadi. Ajiar Diawan. Mr. Gegi, are you ready to present this morning? In this session, I mean, it's not in the second session, which is in the afternoon session. No? No one for the second session already to present in this first session, which is this morning session. Okay, we have to close. Okay, we have to close this meeting. We'll continue in the next session. We still have 10 minutes. Yeah, 10 minutes actually. 15 minutes. 15 minutes actually. We have 15 minutes. But no one for the presenter in the second session already to present in this session. So we have to break one into 9:30 AM, and we'll continue to opening ceremony and plenary speaker from 9:30 AM to 12 PM. Okay. Thank you for your wonderful presentation, everyone. Ladies and gentlemen, Mr. Prabot, Mr. King, and others, Mr. Rehan, Almira, and others. Thank you very much for your wonderful presentation. Big applause for you.
Thank
Big
you.
applause for you. Hope this session has enlightened everybody in this room. We can go back to the main room to join a plenary session because we will have two great keynote speakers today. You already know for the keynote speakers today, which is Mr. Ono from Indonesia, right? And also one is from Malaysia. But let's take a group photo to capture the awesome moment. Would you please open your camera, all of you, for the presenter or the participant here? Wait a minute. All of you, please turn on your camera because I will take the picture. If Mr. Abdul Rakib cannot, the camera is off, Mr. Abdul Rakib. It cannot on. Okay, Mr. Fajar, yeah, Mr. Prabot and others, please open the camera. We take pictures as a proof for EA. Okay, Mr. Gagi or another? Ridwan, Royan Habibi, Abdul Azam Erlan Inkerwang for the participant from ITTS, yeah, from ITTS. This is a student from ITTS College, Institut Teknologi Tangerang, Selatan. Okay, Abdul Azam, Gagi Ajiardiawan, Ben Ali, and Ridwan Prasetya. Okay, 1, 2, 3. Okay, give applause for you all. Thank you very much for the presentation. See you in the next sessions. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Mr. Dewangga. Thank
Yo,
you.
thank you all of you. Thank you so much.
Mr. Dewangga.
Yo, thank you so much.